Okay, this is probably going to be one of our most important videos. Um, we're going to talk about dimensional analysis. This is a problem solving method that will save your bacon. Um, right? I hear a lot of people complain about having to memorize stuff and formulas and all that kind of stuff. Dimensional analysis takes a lot of that out of you. Okay, this is a process for solving problems, and we're going to work through it. So I have two videos for this. This one is how to do it, and then we'll work a bunch of examples. Okay. Um, but the idea here is that you're going to use the units to to tell you how to work the problem. Okay, this will work for just about every problem we have. Um, I will tell you this though: you have to use dimensional analysis uh, if there is not an equation that you're supposed to use. Okay, and there's even some things with this. I would default to use dimensional analysis on everything that's possible. So what I mean by equation is like the temperature conversions were equations. So you don't need dimensional analysis to do that because you have the equation to do the algebra to do it. Okay. A lot of our thermodynamic stuff and gas stuff has equations to go with it. Um, but dimensional analysis will be helpful there as well. All right. So let's get into this. What exactly do I mean by dimensional analysis and using the units to do it? Okay. Let's take a stab at some symbolic examples. I found this when I was looking for interesting pictures to include here. So we just want to I want to think through this as we go. Okay, so we know that if you multiply something or divide by something, right, things happen. So if we look at this, right, so this orange thing and this on top and this orange thing on bottom will cancel each other out. This blue one on top and this blue one on the bottom will cancel each other out. So the only thing that's left is triangle, and so triangle comes our answer. This is how we're going to work with the units as we do stuff. Okay. Same thing happens on the bottom, although this one isn't as clear. Uh, it's not as neatly set up as the first one. Okay, we have a red stop sign on the top. There's a red stop sign on the bottom. There's a star on the top and a star on the bottom, which leaves us a heart on the top and a lightning bolt on the bottom, which our answer is heart over lightning bolt. So that makes sense. Okay. Um, Now we can use this idea to literally solve what we're talking about. Okay, so here we have this pokey looking thing and this pokey looking thing, so they're going to cancel each other out. And we have a diamond on top and a diamond on bottom. So this means our answer should be what? Orange circle. I don't know why I feel compelled to draw it, but there we go. Orange circle. All right. Now, in the bottom one, this number 4, uh, it's not asking for the answer. It's asking for what goes here. Okay. Our answer is smiley face. This box canceled. This box canceled. We have donut times smiley face divided by something has to equal smiley face. So this means the bottom one here has to be donut. So the donuts would cancel out. Okay. We're going to do the same idea, but we're going to do it with units. Okay. And let me explain how this is going to work, because some of this math we already know. We just have to remember that we're putting it into the context and realizing that we know what we're doing. Okay. Um, what we're doing is we're going to be using conversion. Let me see what, yeah, okay. We're going to be using conversion factors and equalities. What does this mean? Okay, well, equality is two things that are equal to each other, right? So if we're going to say x is equal to x, well, that's an equality. We set that up. We could even say, well, x is equal to y, and that just means they're two things that look different, but their meaning is the same, right? That's a math thing. If we want to put data with it, we could say, well, 2.54 centimeters is equal to 1 inch. So here we're converting a nice metric unit to a weird imperial unit, but it works okay. This is an equality. It means physically those two numbers represent the same distance. Okay, 2.54 centimeters is the same thing as 1 inch. Okay, I use this as an example here because this thing is exact. And when it's exact, we have to memorize it. Okay, so eventually get that stuck in your brain when we want to do that. Okay, now what's nice about equalities, right? Because the two things, right, the two things are equal to each other, right? We can say, okay, take them and divide them by each other, right? If we said x over x, that's going to equal 1, okay? Right? That makes sense, right? Uh, Same thing here. If we have x over y, that equals 1. But because they're equal to each other, we could also say y over x is equal to 1. Right? Math is full of these fun little things. We can do the same thing with these measurements that we just had, right? We could say 2.54 centimeters divided by 1 inch, because those two things are exactly the same distance. Then physically, we've canceled them out and they're equal to 1, right? Because they're equal, we can do it either way and say 1 inch over 2.54 centimeters. This is also equal to 1 because, again, those are physically the same distance. Okay. Now, dimensional analysis is the process that lets us figure out which one of these two fractions is going to be the one we want to use when we do the problem. And when we look at this, we're going to end up multiplying a bunch of fractions. Let's look at one more thing. Okay. The idea of multiplying by 1, right? I just want to remind us that this exists, right? If we had z and we take z and we multiply it by 1, we're going to get z. Multiplying something by 1 does not actually change the value of it. Okay, right? It's the same thing if we said, okay, z, but now we're going to multiply it by x over x. Well, x divided by x is 1. Z times 1 is equal to z. It's the same idea. Okay, so when we're multiplying and working with these conversion factors, we could say since 2.54 centimeters over 1 inch is equal to 1, then whatever our thing is, so if we said we had, I don't know, we're going to say we have z and we multiply it by 2.54 centimeters over 1 inch, that's equal to 1. We didn't change the value or the meaning of z. We've just changed the way we've represented the value. Okay. So when we're doing this, we're going to end up doing things that look a little bit like this. We look at a little algebra here, and then we'll do some dimensional analysis. So if we had 4x and we multiplied it by 3y over 2x, right? Notice our x's are going to cancel each other out. We're going to have 4 times 3 is 12 divided by 2, which is 6, and the x's canceled out, so we have 6y. This is dimensional analysis. Okay. Don't let the terminology scare you. We know how to do this. All right, let's look at an example. All right, we have 2.67 gallons of water, and we want to know how many liters of water is that. Okay, now we're getting into converting things, and this is probably scary, so let's think through it. Some conversion factors you'll be given, and some you're expected to know. So I expect you to know the metric prefixes. I expect you to know how to convert between the metric prefixes. What's the word I'm looking for? You'll be given these weird imperial unit conversions. So here we'll tell you that 4 quarts is equal to a gallon and that 1 quart is equal to 946 milliliters. So using this, we can figure out uh, how many liters this amount of water is. All right. First thing we want to do is come up with a plan. Okay. Look at the data, look at the problem and see what we have and where we want to start. Finding where to start is a good point. Look for a piece of data in your problem. This one's relatively straightforward. Our piece of data says we have 2.67 gallons of water. So 2.67 is our starting point. Okay. Ultimately, so we got to start with gallons. We're going to end with liters. Okay. None of our things that we know are gallons and liters. Okay. But here's gallons, and we can get gallons into quarts. So if we take gallons and turn it into quarts, we can do that. Once we have quarts, we can turn it into milliliters. All right, milliliters is close to liters. So to get to liters, we're going to have to remember our metric prefixes. Okay. And that is saying that there's 1,000 milliliters equal to 1 liter, or you can phrase it the other way around, 10 to the minus 3 liters equals 1 milliliter. Both of those will get you there. Okay, this is the way I do it because I don't like these negative exponents. This is the definition that we're given um, for the metric prefixes. Either way works. Do not jumble these up. Okay, otherwise you're going to be off by a factor of 1,000,000 because you've done 1,000 the wrong direction twice. All right, now I have a plan. We're going to set it up. And this is how I always set up my dimensional analysis stuff. Okay, you may have seen other things where they look a little bit different, but the math behind it is always going to be the same. All right, we're starting with our gallons. We were given 2.67 gallons. At the start, I always put this over 1. We want to remember that that number we have is on the top. Okay, we're going to multiply it by our quarts to gallons conversion factor. We want to set it up so the gallons cancel out, which means gallons has to go on the bottom, which means quarts has to go on the top. Okay, there's 1 gallon for 4 quarts, so that's 1 gallon and that looks like a 1 gallon to 4 quarts. Okay, then we're going to multiply again. So we've got gallons to quarts. We need to get quarts to milliliters. We want quarts to cancel out, so we'll put quarts on the bottom. Okay, that means milliliters has to go on the top. And look here, we have 1 quart is 946 milliliters, so that's 1 quart is 946 milliliters. Okay, so we did that step. Then we got to get milliliters to be liters. Oops, I don't want equals, I want multiply. All right, so we want milliliters to cancel, so we'll put milliliters on the bottom. That puts liters on the top. Okay, then we want to look at this. It's 1,000 milliliters for a 1 liter. Okay, now theoretically we should have this. Make sure our units cancel out. You don't have to show them canceling out unless you really want to, but I'm going to for this one. Gallons cancel, quarts cancel, milliliters cancel. We're left with liters. So we know we're going to get the answer in liters, which is what we're looking for. So that's good. Now we're going to do the math. All right. Sometimes this gets tricky. Okay. Doing it in your calculator, this can be a little bit hairy sometimes. But the best way to do this is to multiply across the top and write that down. So 2.67 times 4 times 946. It's a big number, 10103.28. There's a decimal place right there. Okay, and then multiply all the way across the bottom. So 1 times 1 times 1 times 1,000 is 1,000. Okay, and then we're going to put units on this. All that's left is liters, so this is liters. Okay, then we're going to divide those two things. So that divided by 1,000 is 10.10328 liters, units on everything. Okay. Now, the last step of this is we got to figure out what our significant figures are. Okay, let's go through this. Okay, this is 3 significant. All this is multiplying and dividing, so we're just going to worry about 3 significant figures. About about the significant figures. This is exact because it's in the same unit system. This is 3 significant figures because they're not the same unit system. This is a metric prefix, so this is exact. Okay, it's 3 significant figures, 3 significant figures. So our answer should have 3 significant figures, which means 10.1. So we're going to round this to 10.1, and that's our answer, 10.1 liters. Mark it as your answer. Okay. I'm going to work some more examples in another video. If you have questions, let me know. We're going to do this a lot. All right. Hang in there. We got this.